Welcome to day 15 of the Intuitive Calculus course. Today we're going to start to study integrals, and we're going to introduce today the concept of indefinite integral. Until now we studied derivatives, and when we saw derivatives we wanted to solve the problem. Given a function f of x, we wanted to find its derivative f prime of x. And what we want to do now is to solve the inverse problem. What is the inverse problem to this problem? It is the following. Given a function f of x, we want to find another function f of x such that f prime of x equals the other f of x. Or we can write this in other simpler terms, like this. Given f prime of x, we want to find f of x. This is the inverse problem to this one. When we studied derivatives, we started here and we wanted to get here. Now we start here with the derivative, and we want to find the function whose derivative is this function. So a function f of x such as this one, that is such that f prime of x equals f of x, is called a primitive of f of x. A primitive of f of x. Let's see an example of this. Let's consider the function f of x equals 2x. We know that if we take the function x squared, its derivative is 2x. So we found the primitive, a primitive of this function, one primitive. Because as we're going to see, there could be many primitives to a single function. And let's talk about that. Let's consider the function f1 of x equals x squared plus 1. We also have that the derivative of this function is 2x. So we got another primitive of f of x. And in fact, any function of this form, that is, any function that equals x squared plus c, where this c is a constant, it is any number, we'll have that the derivative of this function is also 2x, because the derivative of a constant is 0. So any function of this form will be a primitive of f of x. And well, this is quite easy to get to, it is quite obvious. But now the interesting part is that all primitives of f of x will be of this form. That is, given a primitive of a function f of x, all its other primitives will be of the form that primitive plus c. That is, if you want to find all the primitives of a function, you only need to find one. Then all the others will be the same primitive plus a constant. And in fact, this is a theorem that I don't want to prove it here, because I put the proof in the guide that you have access to for this lesson, and you can see the proof there. It only uses the mean value theorem for derivatives. So now that we know that fact, we're going to define the indefinite integral of f of x as this symbol. The indefinite integral, and we use, for the indefinite integral, we use this notation, this very fancy notation, this symbol that looks like a big S for integral. And this is read the indefinite integral of f of x dx. And here the dx, well, it won't be easy for you to understand why this dx is necessary now, but you'll see, especially when you get to definite integrals, you see why this dx is used here. But now you can think of this dx as indicating what is the variable. We're integrating this function with respect to the variable x. And we're going to define this symbol here, and we call it the indefinite integral, as f of x plus c. Well, where f of x is a primitive of f of x. This is the definition of indefinite integral. And let's see an example of this. We already found an indefinite integral. We know that the definite integral of 2x dx is x squared plus c. Why? Because the derivative of x squared equals 2x. Or in other words, x squared is a primitive of 2x. And this is how you find integrals. To find the integral of a function, you try to find another function whose derivative is this function. Or in other words, you only need to find the primitive of this function. In the following videos, we're going to see more examples of how this is done. That's all for now. Thank you for watching, and see you next time.